So we've talked about different ways of measuring moisture in the air and representing it. And one that's very common and will be used throughout this course and probably throughout your life is relative humidity. And it's called relative because it doesn't give you the actual amount of water vapor in the air, but it gives you the ratio that depends on the temperature of the air, because the temperature determines how much moisture the air can hold, and how much the water vapor of the air is actually holding. So there are a lot of charts, and in the assignment this week, you will see a chart that will allow you to look up the actual amount of moisture in the air and the amount of moisture that, based on the temperature, would be necessary to make the air saturated. So we can demonstrate this principle with the following graph. Basically, if we hold moisture set, so the amount of moisture in the air set, and let temperature change, as temperature decreases, the relative humidity is going to increase. As temperature increases, the relative humidity is going to decrease. Now, using these factors, and the chart you'll see in your assignment this week, you can do some calculations. So, if you're using either of these variables, vapor pressure or mixing ratio, you can use temperature to look up the saturation variable, so saturation mixing ratio or saturation vapor pressure, and you can use the dew point temperature to look up the mixing ratio, represented by W, and the vapor pressure, represented by E. So say you look up on this chart the dew point temperature, and it comes up with a mixing ratio of 5 grams per kilogram, and you use the temperature and look up the saturation mixing ratio of 13 grams per kilogram. You can use this equation, really, really basic, and multiply by 100, and you get 38. Similarly, if you looked up the dew point temperature for vapor pressure, and say a different dew point temperature gave you a vapor pressure of 12 millibars, and a different temperature gave you a saturation vapor pressure, so the amount of moisture that wouldn't be necessary to make it saturated, as 48, again, simple math gives you 25%.